there's a way of writing very long numbers.
Yeah. Well, long, what you mean is very large in value.
No, they can be.
Well, how would I write 1.382643219482763321 in standard form?
Wrong.
That's already in standard form. It's a very long number.
Oh, yeah.
So standard form, just to remind you, it's when we were doing this, yeah? Standard form, we had that rule, didn't we? Something multiplied by 10 a certain number of times, where k is an element of the set of integers. So k here, the power of 10 needs to be either a positive or negative integer. Okay, so I said here 1.89 times 10 to the power of 2 is another way of writing 189. Now I probably wouldn't bother writing this instead of this. Why?
It's like a small number.
I've made it longer, haven't I? It's a small number and I've made it longer, more stuff to write out. Okay, I've not made it any simpler to work with. That's just an example of how that one is standard form and this one isn't. Okay, so we went through this exercise about writing certain ones in standard form. So just to recap, 5,500. How do you decide on the 5.5? Yeah, come on.
Because A would remember that the 10's being times by has to be small, bigger or equal to 1 and smaller than 10.
Yeah, so it's got to be between 1 and 10. So basically, we look at this first number and then the next one needs to be the decimal. So in all these numbers, this is the number, then we have a decimal. This is the number, then a decimal. This is the number, then a decimal, and so on, yeah? That's what it needs to be standard form. You take the most significant number, the highest value one, and you write that as the whole part, and then all the other numbers come after a decimal point. And then we have to figure out, if it's 5.5, that's nowhere near the number it was at 5,500. So how many times do I multiply by 10 to get it back to being the same value as 5,500? Okay, and the answer is 3. All right, multiply by 10 3 times, which is the same as multiplying by 1,000. Okay, this one, however, 2.3. Okay, 2.3 has to be multiplied. So 2.3 has to be multiplied by 10 7 times to give it the same value as 23 million. All right. What was different about these ones compared to these ones? Aidan?
No, it's not the same with that. Well, with D and E, they already had a decimal, like they had a decimal.
Well, that's not what I'm thinking about, but I assume. Cameron S. Simon. Leave his book alone. Focus on your own. Steph. Well, if I'm looking at this one, there's actually no more work to do. It's doing something rather than another one. So rather than multiplying by 10, I need to divide by 10. So it's the same thing. Look, we take the 7.8, but to get 7.8 to be the same as 0.000078, I don't multiply by 10. I have to divide that number by 10. But standard form says it must be multiplied by 10 to the power of something. So we looked at it and said, well, how do I get the same as multiplying by 10 but dividing by it? Is that it? So we use a negative exponent, because what does 10 to the negative 5 actually look like? So it'd be 7.8 times, what is a negative? Yeah, good. 1 over 10 to the power of 5. And if you multiply by a fraction, you're actually going to be dividing. So that's how we get past that. So actually it seems a bit like, well, why can't we just write the same power but divide instead? But that's not standard form. All right? Got it? So let's have a look then. So if I want to write in standard form, you can tell me an answer. If I want to write in standard form, or if I want to write in standard form. So what would I do? So you tell me, you do them now, and then tell me in a moment. So remember then, just as a hint, we take this number, this number, this number, they're the important ones. So what's the decimal part, Desmond, for the first one?
For the first one is 3.76
So we do the 3.76.
times 10 to the power of 6.
Okay, so if I write the 3 there, because that's where that 3 is in the units column, how many columns do I need to move it up? Once, twice, 3, 4, 5, 6. So it needs to be multiplied by 10 6 times. Aidan?
The second one is 5.02 times 10 to the
Negative
5.
negative 5. Yeah? And this one? Remember I said this is the one that confuses people? Jasmine?
2.392. I mean,
Yeah.
Times 10 to the power of
10 to the power of 7.
6.
I'm just going to go one way or the other. Which?
Oh.
It's not 6. It's 5, isn't it? Are you sure?
No, it's 7.
It's 7.
Yes.
Yeah.
Down, so they have to times it 1.
Did you say 7?
Yes.
You're right, aren't you?
Yeah.
Because if we think about it, yes. Go on, and I explain. I'll let you say move it as long as you're talking about numbers, not decimal places. So this here says move all these numbers left, how far? 6 columns. Right? 6 place values, 6 columns. So if I change 23.92 to 2.9, which way have I moved the numbers? The other way. So I'm actually adding another column that needs to be moved, aren't I? So Jasmine was right when she said, actually, we've now got to multiply it by 10 another time. All right? But those are the tricky ones. Right, here's a question for you then. Oh, actually, first of all, I was just looking up context. Why do we need these? Well, we have to do some calculations. You all know about E equals mc squared, don't you? Is it? Yes. You don't know it? How can you not? This was courtesy of Mr. Einstein, right? And what it basically proved is that light has mass, all right? And it's E equals mc squared, where E is the energy something has. Okay? M is its mass, and you multiply that by the speed of light squared. Pardon? C is the symbol for the speed of light.
SOL.
So what is the speed of light? Thanks for that thoughtful, intuitive answer there.
Big number.
It is actually, does anyone know it, Cameron?
Is it 3.3 times 10 to the 8?
Almost, it's not, I don't think it's 3.3, it's 2.8, but we actually say 3, roughly 3, times 10 to the power of 8 meters per second. So light travels at, well, it's much easier to work with that. So if I wanted to do, here's a question for you then. If I wanted to work out something with my equation and I wanted to know what c squared was, I have to do 3 times 10 to the power of 8 squared.
It's a big number. Yeah, sure.
All right, but what is it? This is not a throwaway one now. This is where you need to know how to do it. And this is where I will then complain when you say, I don't know how to do it. And I say, well, you weren't listening. And you'll go, yes, I was. And then you looked and grinned and blah, blah, blah. Desmond.
So C is, I think, 300 million or 3 billion? 3 trillion. 3 trillion? Okay, so 3 trillion, so that's 27 something. Wait, no, it's 9 something.
Think about what you've just done, Jacques.
So it would be 9 times 10 to 64. No, to 16.
16.
Because it's big number.
Yes, but we've just, well, I will see whether you understand or not on your test, because we've just done what you do if you multiply powers either side of a bracket. Yes? You multiply them, don't you? Okay? And this becomes also on there.
It was 1.
So we've got 3 squared times 10 to the power of 8 squared, because when you multiply something, what do you do? When you square something, what do you do? Times it by itself. So we've got 3 times 10 to the power of 8 multiplied by 3 times 10 to the power of 8.
No, because it's the same thing, so you add it.
So this time, 3 times 3 is
9
not 6 if we're adding them. And if you're multiplying the same base, you add them, 8 plus 8. So we get the same answer, luckily, thankfully. Okay, so there's one use for it. Any chemists in here, future chemists? Anyone know the rough size of an atom in meters?
It's about 0.
Is it like, I think it's like 2 times 10 to the power of -18.
Not quite. It's somewhere between 1 to 5 times 10 to the negative 10 meters, also known as nanometers. Yeah. Yes, Slim.
Is it 4?
No, the atoms are different sizes. They're from basically 1. So you can see how if we're going to work out sizes of atoms and sizes of molecules and things like that, we need to be able to work with these numbers, because how would I write that? If I was going to do a calculation, I'd have to write 0.
You have to write 100 zeros, right? Yeah, 100 zeros. Yeah.
What do you mean?
Oh, no.
It's not that many, it's just that. Meters.
It is?
Yeah.
Like 10 to the...
Alright? So I'd have to write that, and every time I wanted to write that number, I'd have to write it like that. So it's not very good, is it? So this is why we've got standard form to work with numbers. Okay? So what we need to be able to do is we need to be able to calculate with standard form. So I'm going to ask you to see whether you can add 2 numbers in standard form together, however you wish to do it. Let's see what you come up with. So I'm going to ask you to add 4 times 10 to the power of 3, and I'm going to ask you to add that to 2 times 10 to the power of 3. Okay? And I'm going to give you another one, which is 2 times 10 to the power of 5, add 3 times 10 to the power of 3. I would like your answers in standard form, please. Right, so, guys, here. First one, well, it depends how you want to do this, whether, like, again, those people that get it right first time, even if they don't understand, really, have gone, well, how can I put it in a way that I do understand? So they go, oh, Pot's given us quite a small one. So let's just go, that's 4,000 plus 2,000. What's the answer? 6,000, which is 6 times 10 to the power of 3. I go, ooh, what does that look like? Because that's not wrong. That's fine. That's good. That's not wrong.
I got it.
I perfectly same. So it looks like, look, 4 plus 2 is 6, and the 10s, well, they're the same. All right? Then I go to the next one. And if you fell for the trap, you'd go 2 plus 3 is 5 times 10 to the power. The powers are different. So although I didn't add the powers last time, I'm going to do it this time because it's probably right. I've got no basis in fact or thought or anything for doing that. It just, why not? That's quite often what that's the only thing I can read into some of your work sometimes. So let's put 8. No, maybe 8. Let's pick in the middle. 4 works. No. So what we do is we go, well, what would that power be? So then we start actually going, because we're a smart bunch and we know that actually it can probably solve this with a little bit more thought. And we go, well, let's actually write it. Okay, is that enough?
No, one more.
Plus, well, now if I line those up, I know how to do column addition since I was 2 3/4. So I now know it's 2, 0, 3, 0, 0. Look, it's not 5, it's actually 2.03 times 10 to the power of 1, 2, 3. Oh, it's the big one. Okay. So we need to be very careful, and we all now write in our notebooks and say, don't fall for Mr. Potts' trap with standard form. Okay? So when you add numbers together, it is important to note the value of those numbers. All right? Standard form makes everything look... Oh, sorry, have I gone over? She's packed up already. There's me, I thought I had a minute left. Eyesight, eh? Getting old, obviously. Right. Standard form makes everything look the same. Makes everything look like it's got the same value, but you have to know how to read it. So now you know that when we add them, or even subtract them, okay, you don't. You have to consider the value that those times 10 to the power of gives you. Now what we've done today, we've added and we have also multiplied. Which one was easier? Really? I don't multiplication, because that uses my laws of exponents a bit more, doesn't it? And we add the exponents and we multiply. Yeah. So actually the ones to consider a lot are the adding and subtracting. They're the ones to be careful of. All right? Tomorrow we'll have a quick talk about what happened in your test. Have a good evening.